Good morning, it's Martin again at Wainwright's. Start of a new week. Got a brand new pump. Well, it's Euro 6 pump, so 2016 on Transit, 2 litre. It's a Transit custom. Brand new pump to us, not seen this one before. Story is engine rebuild after an engine rebuild and no start condition, no fuel pressure. New style pump, well, single piston generation. So we'll just start it and we'll see how we go. Right, so I've set it to do 150 RPM, which you can see it's only going very slow. Set it at 1200 bar, and there we go. It's making 1200 bar more or less at 150 RPM. I've got no test data for this, so I'm testing this using the test data for a Euro 4 Transit 2.2. This is a 2 litre vehicle. But because it's a single piston generation, what they'll probably do on the vehicle will probably spin that pump quicker compared to engine speed. So that's because it's only got a single piston generation, but inside the pump there is 2 lobes on the camshaft. So right, what we'll do, I'll just take it up to 1350 bar, which is generally what you normally test pumps at, or we do anyway. And we'll take it up to 1000 RPM. Right, 1000 RPM. Instead of it having 49, the minimum of 49 litres per hour, we've got 21. Obviously this isn't the correct details for this pump because we don't have any, and you've just got to sort of evaluate, because that's only got a single piston generation. Look, like I said, we'll move that quicker. So then we're going to 2000 RPM, and you can see it. The flow's changing with engine speed. There you go. I'm sorry I'm waving the camera about, but I'm trying to do everything one-handed. Right, turn it off. Right, so it's making pressure. It's making enough flow for it to start on cranking. So what do I think went wrong with this pump? Well, inside this pump there's a piston, and underneath this piston, like most of these sort of like new generation pumps, there's a roller at the bottom. The roller is not held in position with anything really. It's only the pressure of the spring on the top of the pump that holds it in position. What can happen, and it's a bit of a warning, when you fit any of these sort of pumps with one piston generation, you must use a scan tool to bleed the system correctly, because if there's any air in that pump, the little roller at the bottom, which I think what might happen with this, it turns 90 degrees and it holds the piston to the top, then you get no pressure. I stripped this down. I had a look inside before I put it on the bench to make sure there's no debris inside that pump. I've put the piston correctly in and now it's working. One thing as well that is slightly different, because all this is new to us, I've had to run that DRV, which is a pressure regulator, at slightly more, so I've been running it at 192 amp, and that's when it starts making pressure. Is that right? I'm assuming so. Everything else looks okay, so what I'm going to box it back and I'm going to try and tell them to try it. If that doesn't work, they're going to be forced to put a new pump on. Pumps for these are slightly over 300 quid, so they're not out and out, brand new from the dealer. And I know there is a problem with them. Like I say, it's the first one we've seen. Now I'll just take a look at the injectors. Like I said, this is a 2016 to present day vehicle, so it's all brand new. So I'll show you how we test the injectors. Right, injector testing. We're testing the electronic part of the injector. I've seen quite a few of the best techs. Now we started using the, well, it's a mega tester, but it's the same as the FSA 050. So we're testing, these are the Siemens generation 6 injector. That's the current one off the new Transits, like that. So that's a piezo injector. Delphi do have some injectors which are piezo, some aren't. You'd have thought that was like a piezo one. I think this is a Euro 5 injector, but in fairness, if you test that electronically, you know that's a solenoid one. I'll show you how to do it. Use an Ohm multimeter onto ohms, pin to pin, on a piezo injector. You'll get just short of 200 kilo ohms. Try to do it one-handed again. Onto this one, which is the Delphi Generation 5 injector. Looks the same. Put the meter on 0.4, so you know that that is a normal solenoid injector. There are some of these you've got to be very careful. Some can be piezo, you've got to be careful. Right, okay. So faulty injector, we use the like I said, the Bosch meter. I'll just swap everything across. Oh. Sorry about the camera work. Try to do everything one-handed. Right. So how do we get to do this test? Like I say, I've seen a couple of other really good techs online using a meter like this now. We've been using it for about 4 or 5 years. Cracking bit of kit, and the Mega one's a good kit as well. Right. We do this test like when you tested this. We're using the Bosch data to test these, which is the Bosch Generation 3. I won't show you the data because obviously there's all sorts of things going on. Right. So we're on to using the Mega tester. Like I say, if you wanted to use that on a Bosch, the Bosch with a D-shaped plug, they have swapped the polarity around. So 2 is positive and number 1 is negative. Doesn't matter when you're doing pin to pin with a normal meter. When you're using this, when you put the charge down it matters. So, and you can damage them. So if one with a D-shaped plug on like that, just about, well, I think all the D-shaped plugs on a Generation 3, 2 is positive and number 1 is negative. I don't know why Bosch did it that way, but you do that. So you have to swap the things around, so black to black, red to red. So we're not testing that at the minute. So just swap it quickly across. Right, this is the correct way around. Right, sorry about the camera work again. We'll look at a, well, this is the common old caddy van, loads of these. I'll show you what a bad one looks like. This is how we test it, right? So really we're using the Bosch test plan to test Siemens. Siemens never released any data, so you've got to start from somewhere. We use a Bosch test plan as a sort of like a stay fast. So right, first of all, turn the meter to 100. I never exceed 100 because you don't want to damage that. On the thing there's a DAR button. Press it till DAR is on the display there, and you just press the button. Right, what we're looking for. This is a really bad one. This will probably run one on this, but you probably get a misfire when hot. Right, so it's putting 35 volts through, and you're getting 25 kilo ohms. That's a bad one. Okay. Right, what I'll do. Oh, we might as well check the Generation 6 injector, the brand new type. So test it in exactly the same way. 100 volts. You'd say if we're 100 volts because you probably won't go much over 125 volts. I wouldn't have thought on most systems. I mean, if you tested this at 250 volts, which is the next click round, you might damage that. Your new injector. Right, DAR again. Press. Now what you should get 106 volts is what it's putting in, and feedback is 198, and it's steady. Everything's steady. They're not floating about out the feedback, and the 106. So that is a really good injector. So if you test it like that, we test it cold, and then we put it on the machine and test it again hot, and you make sure they're both the same. So it's just going from 198 and it's nice and steady. Good injector. Right, other thing what we do, we have a look. Obviously we can't with these because these are brand new injector, these to us. We're going to start seeing them, no doubt, but the 2016 to current. Getting back to the old-fashioned, sorry about the working. Solenoid injector, Siemens, VDO, Continental, whatever you bloody call them. We'll have a look how much the piezo stack expands with current. So what we do, we put the measuring device on. Turn it on. Right, did you see the gauge there? Right, it's nice and steady. We'll just see it a bit. It's 0.000. So what I would do then is to measure lift. First of all, using the same meter, the Bosch meter, go to 50 volts, DAR, and then if you can just see it, zero it again, and press the yellow button, and it's gone to 14 micron. So turn it off. So we can go up another one to 100 volts, DAR. Now you see that the piezo stacker settles. It settles down to 0 again. There. Press the yellow button. There we go. 32 micron. Now this is what I'd never really do. We'll go and see how much it expands with 250 volts. Let that settle. Right, 250 volts, DAR, yellow button. There you go, and it's gone to 77, well nearly 80 then, micron. So that's the actual expansion you're seeing of the piezo stack inside the unit on the top of the injector, which is that there. Alright. So that's how we check a solenoid before we go much further. I hope you find that interesting. I'll get these on the bench now and I'll run them up. Like I said, we've never seen any of these before, so we'll see what they test like. Okay, bye.